So for AC analysis, what we do is we draw the circuit under AC operating conditions. We remove DC sources. So this DC source should be removed. We short circuit the capacitors. So this capacitor will be shorted, this capacitor will be shorted. So you are left with the remaining parts. That is 3 resistances, a voltage input and a voltage output. So the circuit will look like this under AC operating conditions. Once you have drawn the circuit under AC operating conditions, what we do? We draw the hybrid pi equivalent circuit. What is the change from the hybrid pi equivalent circuit and the AC equivalent circuit is we just replace the transistor with its hybrid pi equivalent. So this is NPN transistor, we replace it with the hybrid pi equivalent. So the circuit for the hybrid pi equivalent will look like this. The question is to find input impedance, output impedance and voltage gain. First we go for the input impedance, ZIB, that is the input resistance seen from the base. How much resistance you can see? R pi RE, but the current flowing through RE is IE, so we need to take the resistance from emitter to base. So what we need to do? Multiply it with 1 plus beta. So the total resistance seen is R pi plus 1 plus beta into RE when you are looking from the base. So this is your total resistance. The derivation as I have already told you, but while solving the problems we go in the shortcut method. So you can write ZIB as R pi plus 1 plus beta RE, or again you can do the derivation. You know VI can be written as IB into R pi plus IE into RE. We can write IB into R pi. IE can be written as 1 plus beta times IB into RE. So when you take IB common, you are left with R pi plus 1 plus beta times RE, which is VI. So VI upon IB, which is nothing but ZIB, which is R pi plus 1 plus beta times RE. This is how you can do the derivation and find the equation. So once you have find the equation, you can substitute the values and you can find ZIB as 68.48 kilo ohms. Once you know ZIB, you can find ZI, which is 470 kilo ohms in parallel with ZIB. Why? This entire thing is replaced with a single resistance ZIB and ZI. So the circuit look like you have 470 kilo ohms and you have ZIB. So these two resistances in parallel, when you look from this point, will give you this equation, and the value of ZI is 59.77 kilo ohms. This is how we have found the input impedance. For output impedance, when Vi is set to 0, what you can say? V pi is 0, GM pi is 0, that means open circuited. So your output resistance is nothing but 2.2 kilo ohms, only a single resistance. Now last point is to find the current gain. Now to find the voltage gain, we write AV, voltage gain, equals to VO by Vi. Now VO over here, GM pi is flowing in this direction, that is positive here, negative here. So when you write VO, it will be minus GM pi into 2.2 kilo ohms. Now when you look here, V pi is voltage across R pi and current flowing through R pi is IB. So I can write V pi, V by Ohm's law, V is equal to IR, IB into R pi, right? When I am substituting this V pi in this equation, what I will have? VO equals to minus GM into R pi into IB into 2.2 kilo ohms. What is GM into R pi? I can write it as beta. So minus beta IB into 2.2 kilo ohms. Now the current flowing IB can be written as total voltage divided by total resistance. So I can write this as minus beta into voltage is VI, impedance is ZIB into 2.2 kilo ohm, right? Now this is your VO. We need to find VO by VI. So this equation 1 I am writing again. So I can write VO by VI as minus beta into 1 upon ZIB into 2.2 kilo ohms. So when you substitute the values, should get the answer as minus 3.855. So this is nothing but your voltage gain. This is how you can find the voltage gain. Thank you for watching. In 5 minutes